Hello, welcome. So just a quick note before I start talking about perhaps more important things. There is a gigantic pile of stickers right here. They are free, I promise. I'm not going to come shake you down for cash later. They've been sitting in my house for 2 years. I'm sick of looking at them. Please take as many as you want. They're good for weddings, birthdays, bar mitzvahs, you name it. You can stick them on just about anything. So if you want that, or if you like stickers and put them on your laptop or people or whatever, stickers. People love stickers, right? My name's Eric. I work for a company called Eric Darling Data, which is pretty okay. My boss is a delusional alcoholic, but we deal with it day to day. We cope. There's a party tonight they wanted me to tell you about here. The bar opens at 5, but the party starts around 7. I was going to come. It's an arcade-themed party, right? Video games. And I was going to come dressed as Zangief. So if anyone wants to stand in the parking lot with me and punch cards for a while, we can do that. We can have lots of fun. So, I don't know, whatever. This is feedback, the QR code. If you feel like telling me how awful I am, you can save me a lot of money on dominatrixes in the future. You can put that in my kids' college fund. They'll be very thankful. I will be too. So take a picture of that if you feel so inclined. This is my contact information. If you want to get in touch with me about anything here, on Twitter, website, there's a very common pattern there. There's lots of Erics and lots of Darling Datas, so it should be pretty easy to remember. That's all the slides that I have. Goodbye. No? All right. You want more? Fine. So, no, you can just, what the hell, we'll save you. So this session is called the SQL Server Performance Tuning Tasting Menu or something along those lines. You may be wondering why it's called that, and it's because I like tasting menus. I didn't always like tasting menus. I was a regular kid just like you. And then one day I got bit by a radioactive consultant named Brent, and now I like fancy tasting menus. So that's why I called it that. The first thing we're going to start with is a very interesting thing that happens in SQL Server called trivial plans. Trivial plans are the optimizer's way of sort of brushing you off and saying, yeah, whatever. I don't feel like thinking about this very hard. Optimizer's got a hangover, doesn't feel like doing any work, and so we get stuck with these trivial plans. And there are some weird drawbacks to trivial plans, and we're going to talk about what those are in a moment. But if you if you look at an execution plan, and you do the very, very smart thing, and you get the properties. No. You're too kind. So if you look at the properties of any execution plan, you'll have this section over over to the side there. And if you zoom in on that, I mean, you don't need to zoom it, but you can zoom with your eyes. You'll have this thing called optimization level. And the optimization level will tell you if SQL Server said, yes, dear, whatever, or if the SQL Server really spent some time thinking about a way to get you a really good query plan, or at least an okay one that you might have to deal with later. Yes, thank you. Never quite get the sound right at these things. But you can do some pretty crazy things and still get a trivial plan. Like if you look at this query, like you may be thinking, oh, I'm getting a row number, I'm doing some work. How is SQL Server ever going to cope with this? But no, this plan is still absolutely, positively trivial. And I don't know why that thing keeps disappearing. I should pin that for a little bit. There we go. Oh, no, you just disappeared on me. Thank you. Oh, this isn't going well at all. All right, everyone go drink. All right. Zoom in there. What do we see? This is still an absolutely, positively trivial execution plan. Go away. Things that will get you full optimization, things that will really get the optimizer's noggin jogging about how to get you an interesting execution plan, happen when it has some decisions to make. For a lot of queries, it just doesn't have a big decision to make. The choice is obvious, whether it's the index to use, the operators to use. There's no cost-based decision for SQL Server's optimizer to make. So if I select the top 1,000 distinct IDs from the users table, you might think, oh, distinct. We have to figure out how to make this data distinct. How can we do that? How is the optimizer possibly going to cope with this distinctness? But this actually still gets a trivial execution plan, because we have a primary key on the table. There's one column in there that's always unique anyway, so there's absolutely no work for it to do. It still just says, no, well, we can just scan the table and give you a nice little top 1 query there. And there's like no aggregation, there's nothing going on. This is still a trivial execution plan when we go look at those super important properties. Again, wow. If they start throwing roses over, I know I did a really good job. So if we do that with a column that's not unique, there's a couple interesting things that happen. And this is where SQL Server starts having a choice to make when it gives you an execution plan. So we look at this top one, this top query. We have a hash match of the flow distinct variety. And if you look at this bottom plan, we have a full hash match aggregate right there. What's the difference? Why does that happen? Well, if you look at that bottom plan where it says 5,000 of 4,369, SQL Server says, oh, that's a lot of rows compared to how many rows I think are going to be distinct. I'm going to give you a full aggregate. For the top query, where we're getting the top 4,368, SQL Server says, oh, that's fewer than the distinct values. We're going to use as flow distinct operators. That probably not like unimportant piece of like optimizer jeopardy there, but it starts giving you some insight into how SQL Server has to start thinking about different ways to do things, right? So we had a choice to make. SQL Server had a cost-based choice to make, and so both of these queries will get full optimization, which is probably, I don't know, it's okay. It's not, maybe not the best use of SQL Server resources, but that's all right. This is developer edition, it's free anyway. Doesn't really matter much, but you can see full optimization there. SQL Server sat down, thought about it real hard, took a walk, looked at some birds, looked at some trees. It was fun. So another thing that will get you to full optimization is if you ask for data to be in order, but that data doesn't have an index to support that ordering. SQL Server has to think about what kind of execution plan it wants to put that data in order. Right? Oops, sorry about that. Clear that out. You go away. No, give me the pink one. Give me the pink one. There we go. No whammies. So when SQL Server looks at this query, it says, what do I need to do? I need to sort this data. I don't have an index that puts this data in order for me. Right? B-tree indexes put data in order. That's how it makes things really easy to find and makes all sorts of other nice things possible, like stream aggregates and hash, merge joins and things like that. All that good stuff. Whew, that's lovely. Someone's doing a real good job over there. How do I get you to clap like that? Could you clap real loud like that just to give them some what for? Come on. There we go. Yeah. Yeah. How's it feel? Another thing, and when I was writing these demos, this really shocked and surprised me. So we have almost an identical query there, right? Like there's no real difference between those two queries. We have a select top 100 and then a select top 100 ID equals ID, right? So there's like no difference. Nothing changes. There's nothing interesting about this. But that really simple, weird little subquery gives SQL Server like the willies. It just freaks it out, and SQL Server says, oh no, we need to fully optimize this. We're not really sure how to handle this situation. We've never seen this before. Someday I'm going to get this right with Zoom It. There we go. So 6 glasses of whiskey. All right, you guys too. Come on, good. Yeah. I don't want people watching virtually to think it's just a laugh track from the other room or something. That'd be real embarrassing for me. Or they think I'm doing a real bad job. So following that same sort of like pattern, right? If we add just dumb little things into queries, we can make SQL Server think harder about how it's going to do its job. So these two queries, right? 1 equals select 1. There's no way 1 is not going to equal select 1. It's not going to ever be anything different. It's never going to, 1 is never going to not equal select 1. But if we look at these two queries, the only real fundamental difference is that this query plan is trivial in nature, right? You can see that right there. And this query plan down here, come on back to me, baby. I promise I'll never do that thing again. Drink 6 glasses of whiskey at lunch. There we go. Optimization level full. So that silly little subquery gave us a fully optimized execution plan. All right, come on. Yeah. All right, you slacked a little bit on that one, but it's all right, I'll forgive you. So when does this stuff start to matter? All right, well, trivial plans, again, are the optimizer's way of sort of just brushing you off. They're saying, well, I don't really care about your query all that much. I don't really care about you getting the best possible execution plan as quickly as I can get that out to you. Sorry about that. But where it starts to make a difference is like little pieces of feedback that you might expect, like little things that you use as cues to either make queries faster or to figure out if there's anything you could possibly do that would make things better. And one of those things, and even though missing index requests aren't the most perfect thing in the world, but for a lot of folks, they're useful pieces of feedback. They're like sort of a way to get to more acceptable indexing if you don't have a well-trained human being or at least a decently sober monkey to look at queries and indexes and say, ah, cool, yeah, that'd probably make it faster. So if we look at these two execution plans, that top query, SQL Server doesn't think that there's any way an index could possibly help that thing go faster, right? We got a completely trivial execution plan, and there's no missing index request. The bottom query, where we did put that funny little 1 equals select 1 doodad on there, well, we get a big missing index request for that. And all of a sudden, we start to say, okay, well, really, SQL Server doesn't care about me all that much. Like why is it that this is the difference between me having a better query and not having a better query? And this is because you got a trivial plan, you did not get things fully optimized. Another place that this can really bite you is, as good DBAs and developers and database design type people, we sometimes add constraints to things, right? Foreign keys, uniqueness, all sorts of good stuff. I'm going to add a check constraint to the users table. And this check constraint is going to tell the optimizer that every single value for the reputation column in the users table is greater than or equal to 1 and less than or equal to like 2 million or something. And this constraint is fully not untrusted. This is a very poorly named column there. I wish I could go back in time and tap someone on the shoulder when they were designing this. But we are not trusted. So we are trusted. It's 6 double negatives or something like that. And so we would think that telling SQL Server about that would let this query bail out, right? We see select some columns from the users table where reputation equals 0, and we know, based on that constraint, that there are no 0 reputations in this entire table, yet lo and behold, we hit a query plan that scans the entire users table and did that thing again. And look at that. That's not good. It's a complete waste of time. Right? It's a complete waste of resources. We should have just bailed out. But if we get a fully optimized, this is a revival? You're going to start handling snakes and speaking in tongues next? What's wrong with you? It's a database. If we run this and get a fully optimized execution plan, SQL Server says, no, thank you. We're going to stop right here. We get that constant scan operator. We don't do any I/O. We don't use any CPU. SQL Server just says, nah, I'm done. Get out of here. Go do something more useful with my time. So this is where trivial plans can really start to matter and cause issues, just make your server do more work than it should. Are there any questions about trivial plans? It's totally cool if there's not. I'm happy to answer them, but whatever. All right, let me go through this jumble. And now we're going to start seeing some really interesting stuff. So how many people use an optimistic isolation level, like read committed snapshot isolation or snapshot isolation? Yeah? All right, I love all of you. You're wonderful, beautiful, smart people. Read committed is a garbage isolation level. It's in my mind, it's almost as bad as uncommitted, because all sorts of awful things happen under the read committed isolation level. One of those things is that read queries can block write queries. I know you don't believe me, but I'm going to show you exactly how that can happen. And this is why everyone uses no-lock hints everywhere, just because of the dumb stuff that happens with read committed. It's awful, truly awful. So this is really just an unimportant store procedure with what it does. But the point of it is that we need to get a bad execution. I don't mean that this execution plan is necessarily bad. It's great for this parameter. Right? It's wonderful for this parameter. It's not going to be great for the other parameter, right? We have a pretty simple little execution plan there. We do an index seek, we do a nested loops join back to the clustered index, we do a key lookup, we get some rows. But for that number of rows, that's totally fine. There's no need to go adding gigantic indexes to fix that stuff. There's no need to mess with it. But when we run this and we get go away, Redgate. It's a bad advertisement for SQL prompt, getting in the way of my presentation. We run this version of the query. It takes a lot longer, right? So SQL, our query got parameter sniffed, and parameter sniffing, not a bad thing in and of itself, but this sort of parameter sensitivity is what can lead to other issues, right? So now that nice simple little query took a lot longer, right? It took about 11.5 seconds right there, right? Maybe not so great. I don't want to wait 11.5 seconds for that to happen. So what we're going to do is we're going to take this and put that in a new window as soon as Redgate goes away, and paste U in. And I should probably have not opened all these at once, but you know, again, 6 glasses of whiskey. It's a hell of a lunch. All right, copy U, put U in a new window. And what we're going to do is kick off our bad parameter sniffed version of the query, which runs for 11 seconds. And we're going to run this update. And we're going to run sp who is active with getLocks equals 1. And what do we see there? What do we see? We see a select running, and that select is blocking an update. Boo! Boo indeed. That's not fun. That's not cool. And this update query will get blocked for all 11 seconds that other query runs for. Right? And if we look at the locks, they get taken up here. We see something very important. On the votes table, which is what we're trying to update and what we're selecting from, that's an object-level shared lock. Object-level shared locks are completely incompatible with every other type of modification. So that happens because we're doing that lookup, right? When we get stuck in that nested loops hell doing that key lookup, SQL Server has to guarantee that the rows from the non-clustered index are going to match the rows in the clustered index, and it can only do that with an object-level shared lock that stops the clustered index from changing, right? So that's a hell of an unfortunate situation. Again, read committed is a garbage isolation level. Let's kill this thing off because we don't need this anymore, and let's roll that back. And with the magic of SQL Server 2019 and accelerated database recovery, we don't have to wait very long for that to happen. So, if you see in your life, when you're looking at either sp who is active or another monitoring tool, or you're looking at blocking chains in some other way, maybe you're really cool and savvy and use extended events to look at things, and you ever see a situation where read queries are blocking write queries, there is a very, very good chance that you have a key lookup in the plan that's causing that object-level shared lock and that's forcing your update queries to get blocked behind it. And the longer that happens for, obviously, the worse things get. Blocking chains, things get worse. You know, you introduce more of a chance of getting deadlocks. You know, like when you think about tuning, when you think about thank you. When you think about like query performance tuning, it's really like the way that I like to think of it is the longer a query runs for, it has like a bigger surface area where things can go wrong and get messed up. And so your job when you're tuning queries is to make them run as quickly as possible so that you don't run into situations where things go wrong like this, right? So I always thought that was a very interesting thing. What gets even more interesting is under the completely horrible, deficient isolation level called read committed, reads and writes can also deadlock with each other. And this is something that I've run into in a few places, and people's brains are not happy when they have to start figuring this stuff out because it's really hard. It's really unpleasant. So let's create what looks like a maybe helpful index. Get that going. And while that does its thing, we're going to open up a couple new query windows. And where are you coming from over here? There we go. We need that. And we need this. And again, I should have left sp who is active open because it's just so useful. I end up doing all sorts of stuff with it in this presentation. So let's open this up and get that going. And so in this window, we have a simple select query that's just going to run in a loop, right? It's going to just assign some data to some variables. And over in this window, we're going to run an update in a loop. And that update is going to just flip this vote type ID column back and forth between values, right? That's all we're doing. Nothing big, nothing amazing, nothing groundbreaking. And if we start running this, and this doesn't always work the first time. Sometimes you have to run it a few times, but there we go. What just happened? Our select query deadlocked with a write query. Isn't that horrible? Doesn't that just make you want to go use like MongoDB or something? Right? It's dismal. right? We have a select query that deadlocked with the right query, again, because of a lookup that takes an object-level shared lock and prevents the update from progressing. And we have this sort of fight between which indexes can do what and which indexes are allowed to access things. And I'm going to try to time this exactly right. And hopefully I can do it. Ah, missed it by an inch. Sometimes it works, sometimes it doesn't. I'm not going to spend terribly long on it. Yeah, looks like it's happening a little bit too quickly here. But if you time some of this stuff exactly right, you can see both queries blocking each other right before SQL Server wakes up and decides that that deadlock has to be resolved somehow, and then just ends one of those queries. So under read committed, the isolation level, not only can you have reads block queries, but you can have read queries and write queries deadlock with each other. So again, if you're ever looking at extended events, if you're looking at a deadlock report, a monitoring tool, whatever, and you start seeing write queries and read queries deadlock, there is a very, very good chance that there's a lookup in that read query, and that read query that's what's causing, again, that object level shared lock is what makes that happen. Any questions on that one? No? All right, cool. I'm going to show you another really interesting thing. And this is something, again, I know it's kind of hard to believe that people call me up and are like, you look trustworthy, here's the keys to the SQL server, do something. We have some problems to fix. This is something that I ran into with a client, and this baked my noodle a little bit when I first read about it, because I actually had to call some friends at Microsoft to figure out what was going on there. Oh, let me turn on query plans and redo that. Junior errors, 10 demerits. I'm going to make myself do 50 somethings after this. Make up for it. Do my atonement. Flagellate a little. Not like that. All right, so this query runs for a little while. The query itself, I get it. It's not a finely tuned machine. This isn't the type of thing that I would expect to see a lot of people doing. But some people let some performance things slide. They don't always add new indexes when they add new queries to the system. And so sometimes things start going a little bit south and they don't understand why. This query runs for, if we look at the final tally, just about 12 seconds. That's not really the point of this, though. The point of this is that if we were to create the store procedure that does the same thing, right, with a parameterized top, and we were to run it, and we were to give that parameterized top the exact same value of 38, that query would run for a lot longer. And because I care about you and your experience and your time here at BITS, and of course finishing on time for my lovely orange friends, what do we see? This thing ran for now 1 minute and 16 seconds. Why? Why did that happen? Well, tops are sort of funny operators. Under normal circumstances, if you give them a literal value and you let them run, they will start sending rows from their buffers almost immediately. If you don't, if you give them a parameter, they have to make some choices. And that choice is, it introduces some element of surprise, because it doesn't know if the rows that it's going to start sending are going to be complete, right? It's like are these buffers complete or not? It doesn't matter. You can just start sending rows. Other times, with the parameterized top, you have to start waiting until buffers fill up, because someone could put a really, really big number in that top. You could put the big int max in there, and it would go just absolutely horrible. You'll notice that there's going to be a difference in the way that behaves if we add an option optimize for, and we say, top, you're only expecting a 1, right? We can put in any parameter we want, but you're just going to act like we're expecting 1. And if we do that, the store procedure goes back to the exact same thing, right, as before. It's not great, 10, 12 seconds, but the optimize, telling the top to expect, come on. Jeez Louise. So if we do that, the store procedure goes back to running in just about the same amount of time as before. You're not going to make you clap, don't worry. Your hands look sore at this point. All right. But if we do that, store procedure goes back to normal, right? So again, not finely tuned, but something that's very interesting. You can also do a big, crazy rewrite with row number to find top 1 that's not susceptible to that, but it is sort of an interesting thing to know that if you write store procedures and you're expecting, and you want to give people the ability to decide how many rows they want back from a top operation, parameterizing that can get real tricky. There's stuff you can do to fix it. You know, you can add the optimize for hint. You can do various things, but that's something that you should at least be aware of, because I see a lot of people run into lots of issues with top queries, but that was one of the weirder ones I've ever seen. Are there any questions on that? No? All right. No one feels like clapping spontaneously. I have to ask nicely, right? I know. It's tough to get people to clap when you're telling them about how bad SQL Server is with some stuff. And everyone's just like, oh, I don't want to do this anymore. You can figure out Oracle or Postgres or something. Just get out of databases, go farm something. This is another one of those things where everyone loves windowing functions, right? There's endless blog posts about windowing functions, all the things they can do, how great they are, like whatever. And but there's also a lot of blog posts, I think mostly by Itzik, that talk about how there's like big limitations to windowing functions. Like there's a lot of stuff they don't do, and this is like ANSI, like stuff that's in the ANSI standard that governs what every database like can and should implement for stuff. But this is one of them. Like you would think that if you wanted to get a count of distinct rows, and you wanted to use an over clause with that, you'd be able to, but you can't. This just throws an error. Distinct is not allowed with the use of an over clause. That kind of sucks, because a lot of people want to count distinct data for some places. It's an important thing. I used to have a feedback item where you could vote for this, but Microsoft changed their feedback site to a first-party provider or something after I wrote this, and so that link's dead. I don't know if the issue is on the new one. If you run into anyone here from Microsoft, please ask them to stop doing that. It really messes up a lot of my blog posts that have links in them. Anyway, one way you can get around that limitation with windowing functions is with the use of the mighty cross-apply. Everyone loves cross-apply. It's wonderful. It's like the Girl Scout cookies of querying. Everyone loves it. Samosas. Get Indian food on the brain. Typical day. So this is one way that you can do that, right? Let's run this query. Let's actually turn on query plans first. That's the important thing. That's what most people are here for. Look at some query plans. That's what Rob's here for. Rob. You're always here for the query plans. What does the query plan look like in PowerShell? Yeah, rubbish? Yeah. At least it's not YAML, right? Always something. So we run this. The query itself goes for around about, let's call it 2.5 seconds. Sometimes it goes for 3 seconds, and I look like a much bigger hero for this. But doing this is not great, right? This is not what I call a finely tuned query. And quite frankly, I'm a little bit surprised by this query plan. I'm a little bit surprised that this took as long as it did. Missing indexes and all, you would think that SQL Server would come up with a smarter execution plan for this, because it knows that it has to count distinct rows. So you would think it would do some like earlier aggregations. You'd think it would want to crunch things down to a much smaller number before doing all this work, but it doesn't. It doesn't. It introduces some filtering and some sorting and some aggregating much later in the plan than I would like. Right? There's a filter operator over here that's wigging stuff out, and there's a hash match way over in the execution plan that brings us down to a smaller number of rows, like right at the very end, and that's pretty ugly. And one way that you can get around that is by introducing a completely useless group by. Right? This is like completely this duplicative of the distinct. Right? We have this distinct. It just doesn't make any sense. Just completely useless rewrite. But all of a sudden, the optimizer says, oh, yeah, you know what? I guess you're right, Eric. For once, I guess you finally figured that out. But now, just by adding that useless group by, we can get this down by about to about 1.5 seconds. Again, usually this thing, I don't know. I got very lucky. Apparently, the power here is very strong. My CPUs are like feeling it. So that ran in 2.5 seconds. But if you look at the big difference in this query plan, is that SQL Server decided, oh yeah, we could do a whole bunch of stuff way up front. So we aggregate some data here, and we aggregate some data here. And if you remember the last execution plan that we looked at, that filter operator brings things down to about 14,000 rows right there, before we do the join. And the other execution plan was after the join. And that's like basically fully joining two tables completely unnecessarily. It's like when you do a left join to find rows that aren't there instead of not exists. And SQL Server has to fully join both tables together and then filter out rows that don't qualify later. It's a real bummer when you see that. I don't know, pretty much anywhere. It's kind of a bad code pattern. I don't know. Maybe I should have had that in there instead. A little bit more compelling to some people who are like, "What? Not exists?" I'm like, yeah, it's a natural language extension. So again, this repetitive group by gets SQL Server to figure some things out in a better way. The only real message here, windowing functions, they have a lot of good uses. They can be they can give you a lot of things that were very hard to produce, like result set wise, and like say older versions of SQL Server. How long have they been around for? 2012 now, right? Ages ago, decades ago. I'm not going to look at those two plans together because I just explained it. But anyway, you can do that at home later if you're feeling randy. But windowing functions have a lot of limitations. There's a lot of things that aren't implemented with them. And it takes some very, very tricky rewrites sometimes to produce the results you want and then to get those queries to run faster. All right. Another very strange thing that the optimizer is bad at is implied predicates, especially with OR clauses. And as soon as those indexes create, whoa, look at that. Are there any questions about the last couple of queries? Anything? No? All right. You're just happy to not have to clap much anymore, right? That's over with. How are we doing on time? Fine? 20 minutes? Oh, cool. We're going to finish way early. You guys are going to be in good shape. All right. So, under normal circumstances, if we run a query like this, where we join two tables together, and then there's a where clause that restricts the join columns to a value, SQL Server is very, very good at figuring out a good execution plan for that, which I should turn on. Seems like a good thing to do. But what do you see here? What do you see when you look at the execution plan? Let's just zoom in there. That's fine. We don't need to spread things out too much. We have a clustered index scan on either side of that nested loops join, but that nested loops join has a very interesting little thing on it, doesn't it? It has a little red X. What does that little red X mean? Right there? This little doodad, this sort of useless warning, it's going to tell us that we don't have a join predicate. Right there. Look at that warning. No join predicate. Most certainly do have one, SQL Server. I don't know why you're telling me that I don't. It's right there in the join, right? You saw that join on two columns where. And that's because the summer intern who wrote that warning, I'm not sure who that was. I don't know. Maybe they're here today. If you go look at the details of the scan, each one has an equality predicate on it, right? So this scan went and found that one row. You did it. If you're going to force people to clap, I'm going to force people to clap. You can do this all day, at least for the next 20 minutes. And this scan also has a predicate on it, 22656. So at the join, we know all those rows match, right? We don't have to do any extra work here. We don't actually have to do any work at the join. Those scans did all the work. The join just said, yep, you're good to go. Let's just move on. Another place where SQL Server kind of comes up with some weird execution plans is with something like this, OR clauses. OR clauses, OR clauses, OR clauses. OR clauses and joins are like one of my least favorite things in the world to see. But OR clauses in the where are typically like as long as you have a decent index in place, things work out okay. Not so here though. Not so here. So if we run this query, where we're looking for a count from the comments table, join to the votes table, matching on post ID, where the post ID column in the comments table equals something, or the user ID column in the votes table equals something, SQL Server gets very, very confused, gets a bit flummoxed, comes up with a rather rotten execution plan, right? Does all this work, right? About 5.5 seconds by the time we get there. Don't get me started on repartition streams. It's one of the worst operators. I'm kidding, it's not really that bad. Every once in a while it's weird, but that's why batch mode's great. Gets rid of all those parallel exchanges. But that query plan doesn't really make any sense, especially with the indexes that we have on these tables. If we go back up and look at those, we have index on the votes table, on post ID and user ID. We have two indexes on the comments table. Right? One of them is on user ID, post ID. The other one is just on post ID. So SQL Server has a lot of different points of data and like ways to access data that would make a lot of sense for that query plan. It could very easily seek to those rows and figure out exactly which values we need out of them and which rows qualify, and come up with a much more efficient execution plan for them. But it doesn't. And it's kind of crappy, but one thing that you can do to kind of help yourself out of these situations is by keeping predicates that are going to be from an OR to the same table, right? Because this is effectively the same query. This is logically the same query. We're just looking for the post ID 138 in the votes table instead of the comments table this time. And now this takes no time at all, right? We go from 5 seconds down to basically nothing, right? Those zeros. Woo, that's query tuning, huh? Wow. But SQL Server is bad at this stuff, and that's why we have to be good at this stuff. Creating the right indexes isn't always good enough. Sometimes we have to give SQL Server better information or different information to come up with a better execution plan. I see this a lot in any framework queries where developers aren't like fully in control of which predicates go where and kind of how things end up. But you know, I see this a lot in regular queries too, because someone just like wrote the first predicate they saw that made sense, and well, things went south on them. Are there any questions on that one? No? All right. Smart folks all around. Smart folks who clap when I tell them to do. I'm going to buy you all cookies. So the next thing we're going to talk about is bitmaps. Bitmaps are very, very powerful things in hash join plans, and sometimes in merge join plans, depending on if it's parallel or not. But when you see a bitmap in an execution plan, it's interesting because where the bitmap gets created is not where the bitmap goes and gets used. So let's run this query. Let's make sure our query plans are turned on. Bing that. And when you look at the execution plan, regardless of your thoughts on everything else going on with it, we see the bitmap. Oh, no, come back to me. Zoom it. There we go. We see the bitmap gets created right up over here. Right? Bitmap create. Wonderful. We created an additional way that we can filter things. We can take that bitmap, and under the right circumstances, we can push that way down to the storage engine, so rows don't even like leave disk to go up to the buffer pool when they're under the right circumstances. Because where that bitmap gets used is down here at the index scan, right? Way down here. So this bitmap is filtering out rows while we scan the index. It's doing a great job, and we can tell it's doing a great job because when we look at the estimated number of rows and how many rows SQL Server thinks it's going to have to do work on, and then we look at the actual number of rows that pass through that bitmap, or rather pass out of that scan, it's a very, very small number comparatively, right? It's a much, much smaller number than the number of rows that we had to read through, right? So we read a lot of rows, but we filtered a ton of those rows out very, very early on, which is awesome. That's great. That's a very, very useful bitmap. Good job, bitmap. You get cookies too, gold stars, smiley faces, rainbow stickers, whatever you want. When they're not so useful is when that bitmap gets created because, like, again, best intentions with the optimizer, but the bitmap doesn't actually filter anything. So let's look at this query plan. And we see the bitmap gets created up here, and we see the bitmap, again, gets used down here, but the number of rows, right, it's just not doing a very effective job of filtering things out. Just about every row matched in there. So that's a really, really bad time. Another interesting thing that can happen with bitmaps is I wonder what they're doing over there. Handing out prizes, that's it? I had stickers and no one clapped. Woo! Yeah, thank you. I appreciate it, sound guy. All right, so not always do bitmaps end up where you would want them to end up. Sometimes a bitmap gets created, like here, and that bitmap does not get used where you would expect to see it. Right? Every other query that we looked at with the bitmap in it, the bitmap got applied at the scan down at the bottom there. Right? Didn't happen here. In this case, the bitmap got stuck in the repartition streams. Look at that. What an odd little duck that is. Why would you do that to a SQL Server? What possible good would that do? We had a scan, we had an early aggregate, we could have had that aggregate do a whole lot less work, but no, you did a bitmap with the repartition streams. You'd never do a bitmap of the repartition streams. But think about how many rows you could have not had to deal with at this partial aggregate. SQL Server did a bad job here. So bottom line, bitmaps, great things to see, especially when they do the work that they're promising to do. They filter out a lot of rows, they do a lot of work, they prevent SQL Server from having to do more work later on. Again, early row elimination is one of the most powerful things you can have in a query, whether it's having the right indexes so you can filter down to the right stuff, or applying bitmaps that actually filter stuff. They came close there. Are there any questions about bitmaps, that foolishness that we saw? Anything? No? All right. You guys in a gang? So those shirts, you know, because there's a bunch of orange shirts over here. I don't know if there's going to be a fight later. I'm neutral. I'm wearing brown. Please don't mess with me. I'm gentle. I'm delicate. All right. So now we're going to talk about modification queries, because a lot of the times when people see modification queries, they think there's absolutely nothing they could possibly do to try to tune them. They just have to run and do things, and really you're at the mercy of like doing all those writes and sending stuff to the transaction log, and that's not always true. Sometimes there are very interesting things you can do to tune updates. So this update is admittedly a little bit silly. This where 1 equals 1 at the bottom is only so SQL prompt doesn't warn me that I'm modifying the entire table when I run this. As long as that where clause is that where 1 equals 1, the SQL prompt's like, oh, you're fine. It's like fooling a guard in a video game. It's like, you throw a rock, like, all right, anyway. You look at this thing. Like, I'm just wearing different armor this time. If you look at this query plan, you see some interesting things. Way over here, we have a couple scans of the clustered index on the total score by user table. You have a merge join, and then way over here, you have an eager table spool. This eager table spool is there for something called Halloween protection. It doesn't protect you from Michael Myers or Jason Voorhees or Freddy Krueger, but it does protect SQL Server from running updates in an infinite loop, because it keeps track of which rows it's going to update, and then it uses that cache of data to figure out where updates are going to go from there. Right? So you have this eager table spool. Rows get cached in that eager table spool, and then the update sort of works off that rather than off the result of the merge join. Right? Because like the Halloween problem that this fixes on a regular basis, I guess back in IBM in like the 70s or something, they were talking about an update query where they wanted to give everyone like a raise and like of 10% who made less than $50,000. But the update ended up running until everyone who didn't make $50,000 suddenly made $50,000. Like it just kept updating and updating and updating. They're like, oh, you still didn't make enough money. Here you go. You'd be clapping like those guys if that happened to you. Except they figured out it was just a bug, and they probably took all your money back, sued you, and made you. I don't know. IBM's a weird place. But this update does a lot of work to separate the initial part of the query from the actual update work. So let's reset the total score by user table, and let's, rather than just updating from that query directly, let's store things in a temp table, right? Good old temp table. And then let's do the update from the temp table rather than from that base data, right? Let's use an object that's sort of like a spool to do that same sort of work. So I'm going to stop for a second here while this runs. You'll see that this runs much faster. But the important thing to think about here is that spools are temporary objects. And when I dress as Zangief and find these guys, they're in trouble. I'm going to do that head spin slam on all of them. So when you see a spool in a query plan, it's a sign that SQL Server took data that you wanted to do something with and stuck it in tempdb. Spools have a lot of problems. The rows get loaded into them one by one. Right, so it's kind of a row-by-row operation, which is not good. And you take up some space in tempdb. I've seen some weird tempdb contention stuff happen because spools are just constantly throwing data in there. And then there's also like temp tables themselves have a lot of optimizations for loading data in. There's just a lot more efficient for that stuff. And then right after the query is done, SQL Server throws that spool away, just ditches the cache. And for that reason, sometimes it's important for us as people who do all sorts of fancy query writing things to use what we know about query plans to sort of do that work instead of making SQL Server do that work. Right? So we can take the data that we care about updating dump it into a temp table, which is almost exactly like a spool, except with all sorts of nice fancy optimizations attached to it. And then we can do the update from that spool, and then all of a sudden, we don't need to do that in the update, right? Rather than work off the total score by user table, we can work off the temp table. All of a sudden, we get a much more efficient modification query, right? That went from like 7 seconds down to 2.5 seconds. And that's, I mean, even the load into here is pretty quick too, right? So a whole lot faster than, like there was like 3 or so seconds for the eager index spool in the last one, or the eager table spool in the last one. This is about 1.5 seconds. So you can see that 5 minutes or seconds? 5 minutes, woohoo! I'm gonna finish just about on time. All right, so we have 5 minutes left, and so I'm gonna give you a choice. Would you like to learn about predicates in parameters in views or local variables? All right, everyone who wants to learn about local variables, clap now. All right, who wants to learn about parameters in views? All right, so I'm sending that to the judges. Who won? First one or second one? Second one? All right. You've been overruled. We're going to learn about parameters in views. Very sorry. All right. If I didn't spend so much time talking about stickers and having to make you nice people clap for me, maybe we would have got it both in. Who knows? But if we look at this view, we're doing something that, I don't know, a lot of people end up doing. Again, windowing functions coming back, doing windowing function-y things. And this time we're going to rank people's posts by score. So whoever had a great score, that's what we're going to start ranking each post by. And if we create or alter that view, of course, as one does, and we run that with a literal value, let's make sure that query plans are turned on. That runs very quickly. Runs very quickly. Stickers. Yeah. Yeah, that's what I like to hear. So we have an index seek. All right, fine. No one claps for an index seek. But you see that right there down the bottom. Index seek, scalar operator 22656. That's exactly what we were looking for. Good on us. We figured it out. We have written a very well-tuned, very well-performing query. We used an index. We did a seek. Everything is on our side. The problem becomes if you want to be able to let users get data from that view for any user they want, we put it in a stored procedure. And then we give that stored procedure a parameter that lets users search on whatever they want, because that's what users want, anything. And when we do that, all of a sudden, our query gets a lot slower. Oh, leave it to you to clap for the slow query. That's great. Not smart people in that lesson, I'll tell you that. But our plan changed quite a bit, didn't it? Before we had a nice little index seek and nice thin little arrows, and everything was thin and pretty. It was like a Sports Illustrated issue. I like that. I don't like this that much. This one's a bit out of sorts, a bit pear-shaped. We have to scan the entire post table, and then way over here, we have a filter operator. All right, look at that. This whole thing takes around 7 seconds now. And that's a big difference from the almost instant query results we got on the last one. That filter is on exactly what we're trying to filter on here. Right, this predicate. All of a sudden, using a parameter here was not as useful as using a literal value. Right? And this is where lots of people, like my lazy self included, might just say, recompile, recompile, recompile. You'll never have a problem again. So the differences here, pretty obvious. Let's look at those back to back. And come on, 7 seconds, you can do it. There we go. Right, so very, very different execution plans. Right? Unhappy plan on the top, very happy plan on the bottom. From 6.5 seconds to, that's not good. Don't clap for that. SQL Server is doing a bad job, you maniacs. So the problem with views is that views can't accept parameters. Any query that you write against a view, you have to do your own parameterization. You have to get that stuff in there, roll it your own way. Recompile hint would help. There's lots of stuff that recompile does to allow a literal value to get replaced, or to replace your parameter. But the big thing there is this line. And that is because the optimizer can't push parameters past sequence operators. Right? So when you use a windowing function, unless you're using batch mode and you get a window aggregate, you're going to have a segment and a sequence project and all sorts of stuff like that in order to roll out the windowing function. And that's what SQL Server has trouble with. Right? So SQL Server has to create that whole execution plan, do all that work, right? And that sequence project is where things get stuck. So one way to get around that is to use an inline table valued function. Now this is the only kind of function in SQL Server that I have any respect for, except Scalar UDS, which I respect highly for giving me lots of good demos and clients. Those are wonderful, all day long. How are we doing on time? We're up? Oh, okay, could I just run this one query? All right, I'm going to run this one query and then I'm going to get out of your hair. So we run that, and now all of a sudden, with that in an inline table valued function, we are back to our wonderful fast query plan. Thank you all for coming and listening to me. Thank you all for clapping on demand. Again, there are a bunch of stickers up here that I don't want to take home with me. Please festoon things with them. Hi, Rob. Are you coming to drag me off stage? Oh, you're coming for stickers? Wonderful. All right. Yes.